Okay, floating point multiplication. Again, here you'll start to see the patterns emerge from when we were looking at floating point add and floating point subtract. You'll see same pattern showing up in multiplication and division. So we'll go through these pretty quick. Okay, as we suspect, this is going to pop stack top, and stack top 1 is going to calculate the product of those two and push the product onto the stack top. Okay, in the second one, this multiplies stack number and stack top, replacing stack number by the product. So stack number equals stack number times stack top. Okay, in the last case, this is going to multiply stack top and stack top number. My product is going to replace the stack top. So, next, continuing on with our multiplication, in this case, will multiply stack top and this real value or real memory value. Whoops. Let's go back. Although we love division. Division's so much fun. This is going to, so stack top is going to equal stack top times memory. In this case, I'm going to say stack top equals stack top times memory, remembering in this case that this integer value in memory is going to be promoted to extended double multiplied by the stack top, and then the product will replace the stack top. And in the last case, I'm going to calculate stack top times stack top number, putting the results of the product in stack number. But this one has the P, so it's going to pop stack top after it completes the instruction. Okay? Division. Division, very similar. By the way, we're going to be in class, we'll be doing some example code. We've got a pretty cool example code after this where we're going to write code that calculates the area and circumference of a circle given a radius, so we'll get some practice with this. So it's really important to read over this and watch the video because this is where we're going to go through the rules. I know it's deadly boring, I apologize for that. But better now than in class, although I don't think that's ever stopped anybody from falling asleep in class. Oh well, sad. Division. For division, this is going to do exactly what we think. Pop ST and ST1. Going to calculate ST1 divided by stack top, and quotient is going to get pushed onto the stack top. Okay? Now remember, we're dealing with floating points. There's going to be a floating point quotient, which has both the whole number and the fractional portion of the entire quotient. In the second case, this is going to calculate ST number divided by stack top. Again, it will store the quotient in stack top number. It will replace the contents of stack number. And then finally, down here, this one is going to calculate ST divided by ST number, replacing stack top with the quotient. Okay? Alright, a few more. Got some memory operands. So, FDiv, real memory, this calculates ST divided by memory. Quotient is going to go to the stack top. This does the same thing, except in this case it promotes my integer value. That quotient, which is going to be floating point, will go to the stack top. Finally, FDiv and pop. Okay, FDiv and pop is going to calculate stack number divided by stack top, Quotient goes to ST number, and then finally it pops the top of the stack. Okay? Alright. We have reverse division instructions, similar to, well, very similar to what we had in subtraction. So, for the same reason, there may be times when I need to reverse the order of the operands. Which one's going to be dividend, which one's divisor. And for that purpose, we have reverse division instructions. I'll leave it at this. I want to go over some miscellaneous instructions. Hopefully, there we go. There are miscellaneous instructions. First one, your guess would be right. This is going to calculate the absolute value stack top, replacing stack top with its absolute value. This is F change sign is going to change the sign. So ST stack top is going to equal the negative of ST. Float round to int is going to round stack top to an integer value. Okay, F square root replaces the stack top with its square root. Okay, there are also trigonometric, exponential, logarithmic functions. There are a ton of them. They all behave fairly similarly. So let's go ahead, and that's going to complete most of the general purpose instructions that we're going to be looking at for the floating point processor or floating point unit. But I want to talk about comparisons. So let's go ahead and jump on into that. Okay, I've got some floating point comparison instructions. Each comparison or each instruction compares ST with some other operand, and this is going to set the condition code bits in the status word register. These bits are named C3, C2, and C0. Let's see if I can just write this on here real quick. Yeah, let's do it. So I'm going to make this a little bit bigger and move it up. So here, whoops, we jumped ahead again. So here, let's say our result okay, finally our result will go here. The result of the comparison. Let's look at bit 14, which is C3, bit 10, which is C2, and bit 8, which is C0. Okay? And see what happens. So, in the first case, stack top greater than the other operand. Okay? That's going to clear all of these condition code bits. If the stack top is less than operand, this is going to set C0. And if stack top is equal to the operand, it's going to set C3. Okay? But what if the two values are not comparable? Then it will set all three of the status bits. Okay? So we're going to have to remember that. By the way, the position of these bits is intentional. It kind of makes sense, and I'll just give you a little bit of foreshadowing. It kind of makes sense when we do a comparison that we might want to jump as a result of the comparison. We'll get to that. First, let me show you the comparison instructions. Okay? So, first one, FCOM. This compares stack top and stack top 1. This compares stack top and stack top number, whichever stack register is indicated. This compares ST and the real value in memory. This compares stack top and the integer value in memory. Again, before the comparison is done, the integer value in memory is promoted to floating point, then the comparison is done. And remember, the result of the comparison will set or clear C3, C2, and C0 according to the result of the comparison. Okay? All right. So a couple more instructions let's look at. Float test. This is going to, test. Actually, I could use it to see if a value was 0. It did the same thing as an AND. This behaved a little bit differently. This is going to compare stack top and 0. Okay. FCOM pop, exactly what you think. It's going to compare ST and ST1, and then it will pop the top of the stack. You're going to love this one. This, because I've got two P's here. This compares ST and ST1, and then it sets C3, C2, and C0 according to the results, then pops the top of the stack twice, removing, whoa, that's not good, twice. Removing, so it pops stack top and stack top 1. Okay, cool. Couple more. I think a couple more. Let's try it again. Okay, a few more comparison instructions. First one compares stack top and stack top number, then pops top of the stack. Okay, so all of these are going to pop at the end. This is going to compare stack top and memory, set the bits in C3, C2, and C0, pops the stack after, pop ST, and then this is an integer, so I'm going to compare stack top with a promoted integer value from memory, set the bits, and then pop the top of the stack. Alright. Let's stop here. I've got a little bit more, but we'll do that on the last video.